Welcome back to chapter 5. So we are kind of done with the initial setup of the Stickman, so that we should work on next the Spaceman. And so for that we need to go first into the geo folder Spaceman, and we're going to repeat the steps kind of like the Stickman. So we need to make an animation blueprint. So right click, animation blueprint, based on which one? The space guy skeleton, create, call it AB Spaceman 1. Let's enter. I'm going to close these for now because we don't need to work on them. Also this one here. And again, this one will need a state machine, so right click, state machine, call it, what is it, AI movement. And then let's connect this up here and we can compile. Let's enter and entry. So the structure is going to be very similar to the last one. And so we do first falling. So this is a jump down. And then after that, we're going to do the idle walk. And then the action is going to be the pickup here. And so now we need to make the blend space. So let's do that, compile and save, should be okay. And then let's make the blend space. Okay, so for the blend space, right click, animation, and let's do blend space based on the space guy. Call it BS idle walk 1. I wanted to do 1 because we already have 2 over here. Could be confusing, but it should be all right. Let's open this. And we'll be using 3 animations. First one is idle. It's going to be like right here. We do 0, 0 for both axes. Happy idle, very close. 0, 3. So this, if you remember, is the velocity. And then the walking, which I'm going to set to 0 to 50. Right, and this value is important because as you bring this closer, it's going to affect how fast does the animation start playing at full speed when the walking velocity increases, right? So if I do this longer, this curve is, I think, linear. So it's just going to be like quite slow, right? And if you bring this closer, as the velocity goes up, it's already just going to play at full speed. And I want it at 50. Because I think this guy is going to walk around 75 maximum speed. And I just want it to reach, the velocity curve should be closer, if that makes sense. So for the Stickman, I put it at 35 for a reason, because I just wanted to reach that full animation playback speed at around 35. And I don't want such a long blending time. So hopefully you understood that. And so this is basically it. And of course, we need to apply the velocity here for the horizontal axis. So we should just say, where's that? Yeah, here it is. Let's just call it velocity. Okay, and now that's good. And so this one here, basically, I'm using this when the Spaceman will collide with a Stickman, or it could be an object. It will basically blend into this, and it will create like an effect where they slow down and basically look like these guys here, kind of like looking, yeah, there you go, looking around up and just waiting for things to happen. So I wanted to use that. That's why it's there. And so that's it. So we can just save that. And now this becomes available inside of here. So we just connect this. And this, I want it to automatically transition. So click on this and automatic rule. And so this one here is going to be based on a Boolean from walk to pickup. So this is going to be now promote to variable, can pick up, question mark. And if it's true, it's going to move down to here. And when the pickup is finished, it's just going to automatically go back. So this is going to be automatic rule. All right, so that's that. And so now we can compile and save. And right, we need to work on applying these variables next. All right, so let's work on the variables, or let's just say the animation blueprint, which we haven't touched at all. So of course, this is going to require a speed value. So in the velocity, we just make a new promote to variable and call it movement speed. And we'll just do the same thing over here. In the blueprint event tick, or the animation blueprint event tick, basically this thing here, we just do this. The owner, we get the velocity, we get the length, vector length, and this will give us the movement speed. So drag this and just drop this in the pin, and that'll be it here. And I'm wondering what this thing is. Do I have debug enabled? Not sure how to turn that off, but it should be all right. We can compile and save that. And so this should be ready for testing, hopefully. Right. Next thing to do, of course, is to work on this one here, creating the owner blueprint for the animation blueprint of the Spaceman. Okay, let's do the same thing as the Stickman. So if you remember, we have the blueprint inside of here. So we just drag and do a copy here. And we rename this to BP Spaceman 1. Yep, enter that. Let's open the full editor here and let's go to the viewport. First select our mesh, anim class to Spaceman. Mesh is going to be, of course, this one here. Yep. Now, of course, we need to change the capsule size. So I think it was maybe -30 in the position for the mesh. And then we go to the capsule component. Let's bring this down to 28. Let's go to a front view. And I think the radius might have been 10. Yeah, I think that's about it. Okay, so capsule height, let's just bring it more down to 28. Yeah, that seems pretty good now. So yeah, that's about it. Compile, save that. And for now, why don't we just do the same thing? So just copy what's inside of the Stickman and just select all the stuff and then Control C and V this one into here. I could have copied in the begin play as well, but we can just type that in. Let's connect this. And yeah, this should be good. 25, that's all good. Yep. Right, and then we need to change the values here. And so I found out which are the right values, so I'm just going to bring up the notepad here. And so for the space guy, it's going to be all these here. Yep, so 74, 75, 175. Okay, so I think to slow it down, I increased the gravity scale, and the acceleration was what, 150? Let me just check. And the mass, I somehow made it 50. Doesn't make any sense, but maybe we'll just edit that later. And what? Where's that? The walk speed is going to be what? 74, 75, and 74. As I said, this depends entirely on what skeletal mesh you're using and its scale, but this is the one that's appropriate for the Spaceman, and the braking is going to be 175. And that should be it. Yeah, ground friction seems like I brought it up to 10. And I think the rotation is okay on this one at 500 because I want this guy to be walking and moving a little faster than the Stickman. So compile and save that. Next up, why don't we also just tweak the values again for the Stickman. For the Stickman values, it's going to be these over here. So let's do the same one for Stickman. Let's go to character movement. Gravity scaled to 1.75. And max acceleration, what's that? 55, 55, and then, yeah. So 55 acceleration, and the speed was what, 27? 3027. Braking was 55, and ground friction was 10. I think that's it, right? Rotation speed is probably okay. Yep. And so now we can just compile and save, and we can give it a test with these two guys combined next. So why don't we give this a test? So I'm gonna just drop this guy in here. And I'm just gonna see what, yeah. So this looks a lot smaller than I thought. Maybe it's because it's crunched down. I'm going to bring in more of these guys just to make sure that our colliding animation is going to work fine. And I'm going to just move this back here. And what you need to keep in mind with these character things is that it's very much FPS dependent. So I'm going to have to change the settings of my performance of this PC to make sure we can see it in real time, but the fan noise is going to be very apparent. Maybe you'll hear that. So let me just power that up right now. Okay, so I just turned up my performance settings, and if you play right now, it'll play much faster, or like in actual real-time speed. Okay, so it didn't collide this time. I'm going to make sure that colliding is going to be working. Okay, maybe I'll have to move this guy way closer. And so maybe make sure that it actually collides. Let's play that again. Yeah, you see that? Yeah, there you go. It, let's just say, when it collides with the Stickman, it transitions into the happy idle, as you can see. Yep. And it actually makes it look like it's being stopped. And that's why I placed in the middle animation in the BlendSpace. So you can see that this is actually the real-time walking speed. Okay, I think maybe, you could, as you can see, it's moonwalking a little bit, right? And that's probably because the Spaceman's walking speed is a little too fast. So maybe we just drop it down to 73. Okay, that's probably all right. And we can play it again. Yeah, so it kind of does the same thing for the Stickman. And so we'll deal with the problem here where if they are facing the same direction, it can get stuck sometimes. So this is where the blueprints is going to begin. Okay, let's turn on our programming brains and let's analyze how we can deal with this issue of multiple characters bumping into each other and basically stopping them indefinitely, which is an issue because we want them to keep walking around. And so for this setup, what I want to do is to prioritize the movement of the Spaceman. So we'll just let him roam around wherever he wants. He dictates. And this little guy here, the Spaceman, will adjust to his movement. So basically, all we need to do is to just flip this movement around backwards, and so it starts walking away from the Spaceman. So how do we calculate this vector using vector math? Well, here we have represented where the position of the Stickman is and the Spaceman. And let's just say, the capsule component is like way bigger, something like here, right? So they actually bump into each other, right? And so all we need to do is to take 2 points, we subtract them together, what happens? We get a vector. Now the issue is this isn't normalized, so we need to normalize it so that it's a unit vector. And then I don't want it to just go away by 1 unit. We want it to go away like 50 or 250 centimeters away. So then we just scale this up again by 50 or 250, which will give us a varying kind of distance here, right? And so this is where the Stickman will try to move to once it has bumped into the Spaceman. And so this is going to look a little bit weird, always flipping, perpendicular angle every single time. So what I want to do before we scale it, to just give it a kind of just slight deviation from the actual perpendicular So we can give it like 25 degrees randomness. Okay, this is not 5, but that's it. And then, you know, we get a little bit of randomness, and then after that, we just scale it up. And so we give it a little bit more randomness to the movement. So this is how it would work. Okay, so in chapter 6, we're finally going to do some proper blueprint programming, so stay focused. If you want to keep learning, click on the next video.